I'm just setting up some music for myself, and then I will get to working. All right. So, what I want to do, so I'm starting a new project, and I'm just gonna, record this project from the start to the finish. Okay, so what I'm looking at is a photonic crystal slab, which is kind of like this, and it has some thickness. Okay, so I'll say that, well, these axes are off, I guess. I want this to be like that, I guess. This is Z. I don't know, I don't care. This will just be called Y. This is X. Who cares? Okay. And there's a periodic array of these holes. It's probably a faster way to do this, but whatever. I think it looks kind of cool. All right. Okay, and then these will extend down into the structure like this. So all of them will kind of do something like that, but I'm not going to draw that, obviously. Just for reference. Okay, and this is air, I guess, yeah. So that the index of refraction is 1, and then this bulk material is called bulk of a photonic crystal. It'll have something like n equal to 3 or whatever. It doesn't have to be 3. Could be like 2.7. Could be anything you want. It's just be greater than 1. All right. Okay, whatever. And okay, what do I want to draw now? Now I've kind of messed myself up. All right, fine. And what I want is I wonder if there's a way that I can fill this. That's too much. Okay, now what I'm going to say is I'm going to draw. How big is that? That's kind of good, I guess. So wherever I do this blue color, that means that I'm going to fill, if I draw blue, that means I'm going to fill these holes in. Okay, so what I want to do is I want a line defect. So these holes are getting filled in with some dielectric material. And I'll just fucking do this. Alright. That's a line defect. And it'll continue down into this side of the material. But then I should also color that. Okay. Alright, you get the idea. And later on, I'll want to couple the light in this line defect to some cavities. And I don't know what kind of cavity I want, but let's just say I'll just do a single cavity. So let's say that I just have one of these cavities here. So I can do this in light. So let's say like, I don't know what a light beam looks like. Let's say I were to shine light. So I'm going to shine light onto here. And then this light is going to propagate through this waveguide. But some of the light will couple into this cavity and it will build up in intensity. So that's kind of what I'm looking for. Okie dokie. So what do I need? So on my other screen here, I just I have, oh, and I better save this. I'm just looking for Maxwell's equations. Okay, so I'm gonna have Maxwell's equations. What do I want to do? Yes, okay. So I'll have, okay, well that's the picture. We can always come back to that. But now I'm gonna start doing some LaTeX stuff, I think, because it's, or no, oh, actually, okay. Yeah, first I'm just gonna write down the stuff just to start, and then I'll go to the LaTeX. Okay, but basically, okay, so we have Maxwell's equations. I should put apostrophe S for that. Okay, so the first one, I'm just looking on the other screen. I don't know if I can show this book because it's probably copyrighted. Well, whatever. So BRT, and this is 0. And then I guess I'll write it. I'll just do the divergences on one line. The divergence of the displacement field is RT. And that's equal to the, what is that? I forget what that is. That's like the charge. Free charge. It's the free charges row. And now the curls. So the curl of the electric field. And this is equal to minus dB over dt. Okay. I'll separate them. And then we have the curl of h. And that's, okay, I'm just going to stop writing r and t, but you get the point. That's equal to the current density plus time derivative. And these all depend on position and time. All right, those are Maxwell's equations. Scrolling down to see what I want to do with those. All right. All right, so we're going to make some approximations. So these are approximations. All right, D. This is the displacement field we're going to assume we just have a linear response to the applied field. So that's going to be the vacuum permeability. No, permittivity. This is the vacuum permittivity. And then the dielectric function, which depends on position, times, oh, am I missing something here? Hang on a second. Whatever. Yeah, I don't think that should be as a function of t. I don't think d should be a function of t. In this book here, they don't have it as a function of t. So, I don't know why, but I will also not write that as a function of t. Okay, and then we have to multiply this by the electric field. It's a function of r. Okay, that's first approximation. It's just linear material. Okay, whatever. And the other approximation, well, it's not approximation, is it? Yes, it is approximation. We'll assume that the magnetic field, we'll assume it's a non-magnetic material. I think that's what they say. So you just have, now this one's the permeability, right? Permeability of free space times h of r. These are our approximations. Linear material and non-magnetic. Blah, 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 blah. And I should probably save it at this point because it likes to mess with me. Alright, so moving on. If we sub these into these equations, so sub these approximations into Maxwell's equations, what do we get? Oh, we'll also make another approximation that the current density, there's no free currents and there's no free charge. Okay? So then our new Maxwell's equations are the divergence of B is 0 and the divergence of oh yes, epsilon of r, we just divide by epsilon naught e, and yeah, I want to drop this. Yes, I'm going to drop all the arguments, and that should be a dot. This is 0 because there's no free charges. And I have that the curl of E is equal to minus, and okay, B is mu naught H. All right. I really hope this isn't a waste of my time. Going slow is always helpful, I think. But don't listen to advice. All right. Then this is going to be E naught E, and there should be an R there, but I'm ignoring that. Probably going to mess me up. Okay, so I should probably just like separate these, yeah. And I should save. All right. Okay, where am I? All right, so these are our Maxwell's equations. I'm just gonna scroll through this paper again to see where I go to now. Alrighty. And our next step is okay, what I'm gonna do, or what we are gonna do, just to separate it, is I'm gonna write the fields E and H, I guess, as a harmonic series. So that'll be E. Now this book only uses a single mode, but I will sum over. I'm going to use n. That might screw me over later. I don't know. I'll just go to infinity. I mean, I don't know if infinity is useful or not, but we're going to leave it like that. And this will be E, and I need an N here. It'll depend on position. Oh, it might also depend on frequency. These are all things that we're going to figure out. E to the minus I omega n t. So basically, that's that. And my H field, I'll just do the same thing. So this essentially can be any field. It's just expanded in a harmonic series. Oh, that should be an H. And my frequency, E minus I omega n t. And that's an I. Save that. Okay, moving on. Okie dokie. Okay, so now what happens? I need a new page. Actually, do I want to start from here? Now I feel like I should have done this in LaTeX. I mean, I guess what I could do is I could start with these Maxwell's equations in LaTeX. And, oops. Okay, so let's just go over to LaTeX now. Because, okay, yeah, I kind of know what I want to do. Alright, so sorry if this is, you know what, I'm not sorry. Document, class, article. I'm going to use package physics, because this is physics. And I don't know what else I'll need. I'm probably missing a lot of stuff. Don't yell at me. Begin. Or was it? Is it begin document? I forget. Hang on. I have to check. Yes, I'll just copy and paste what I need. Begin document. Okay. And obviously then we need an end document. Blah blah blah. And let's just see if this works. Aha, it works. Okay. Should we put a title? Well, let's put a section. And the section, see, max, well, not Maxwell's equations, but like field equations for a photonic crystal slab. And you saw the picture. Oh, maybe I should like put the picture in. That would be kind of cool to do that. Use package graphics. But I'm probably just wasting my time doing this. Okay, let's see if this works. Bada boom, bada bing. There we go. Okay, okay. So now we're going to do a little bit of coding for these equations. So say begin, might as well do an array, or a line, I mean. And, oh, I can, okay. And I'll say, okay, for my first equation, I'm going to say do a vec nabla c dot, I think, vec epsilon of vec r, and I need a, wow, writing vec every time is really annoying. And where am I? Yeah, I don't need the vec there. This is equal to 0. I'm just going to test this. Okay, there we go. Paragraph. Oh yes, I have to do an and a line. Let's just see if. Okay. Oh yeah, I should probably put the brackets there. Perfect. And I'm just gonna label this to be Maxwell's equation 1, whatever. Or maybe I should call it like divergence. Divergence. That's good enough. Oh, oopsie doopsie. Okay, and I'll just copy and paste this because I'm probably going to reuse a lot of the symbols. So, okay, so vec nabla, and now I need a times for the cross product. Okay. And I'll have a, well, I can use this vec e. Oh shit, that should be a t. RT, yep, okay. Times, da 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 da. Yes, fuck it. Vec e. Mu not. Okay, now I need to do a frac. Fracking is bad. That's a t, we'll need a partial t. Okay. And what's this one? This one is the curl E. Oops, we're good. And this is curl H. Curl H, and that's just how to switch that to H. And I have to turn that to a plus sign, and this is an epsilon naught, and then I need an epsilon of vec r partial d e. Alright, let's what happens. There it goes. Oh, bye-bye. What's the problem? End a line. Inserted text. Frig. Text 16. This is annoying. What if okay, let's just see if it's good up to this point. Not good up to that point. Okay, so I'm missing. Well, first of all, that should be a T. That's fine. I'm just not seeing it here. Maybe it's here? Yes, so it's somewhere here. Ah, that's our problem. Well, I can't. Let me do that. So I just have to erase this. I mean, okay, this is the problem with copying and pasting, right? Sometimes it saves you time, and sometimes it doesn't. I don't know about you, but there's a problem. I don't know about you, but I see a problem. Language. Alright, so, I mean, what a waste of time, really. Alright, well, I mean, it looks decent. Looks decent enough. Okay, why is it yellow there? If I save this, I'm going to save this. And did it save to the right spot? Yes, it did. Perfect. Okay, so now, okay, those are our equations. Let me just say something here like starting with a linear, non-magnetic material. The Maxwell equations are, and I should probably do like commas here, commas there, period, make it look all pretty. And you know what? Just write out equations, make it look all pretty, and save that. Alright, feeling good, guys. Alright, okay, so I'll expand. Let's say how I wrote it here. So write the fields out as in A, Homer, or in N. Write the fields as a whatever. I don't know how to speak. Write the fields as a harmonic series. Who cares? Okay. Begin a line. Say effect, and let's just not copy and paste this time, because I'll probably make a mistake doing that. And I'm just going to leave it as N, because fuck it. like R, oh shit, not T, this is omega, and have an Rn. I use Rm, I think it stands for Roman numeral. Just makes the E look like a variable rather than like it's not an italic E, it's like a variable E. I heard somewhere that that's what you're supposed to do. Alright, does this look pretty? Oh, I forgot to label things. Let's call it harmonic E. And I'll call this harmonic H. Does this look pretty? Fuck. I'm used to overleaf, where you can just be lazy. This is saved, this is saved. Oh, I think that looks really nice. Okay. Now what are we gonna do? Oh, commas, punctuations, stuff. Even though we're doing math, we still need to use grammar or punctuation. Alright, so now what do I want to do? Let's look at the textbook. When in doubt, look what other people have done. Okay, so let's, you know what? I just want to do this like super slow and boring, like, so bear with me. We're gonna I don't know, people say put, I don't know, put EQs, harm E, and put, I don't like EQs, I'm just gonna use EQ. Put EQ this and EQ harm H into EQ ME underscore div to into EQ to Max's equation. Oh shit. This equation underscore curl H. And what happens? Alright, so sorry guys, it's just gonna be a lot of stuff. Copy that. Okay, so when I put this in here, I can bring this sum out, and this dot product will be applied to each term. I can bring this omega e to the I omega n out. Here I am. Okay, so I'll just bring this sum and this pulled out, and then this just be an en. I think it's relatively simple, right? Yeah. Let's just see what that looks like. Ah, oh, damn it. What don't you like? Missing What don't they like? Missing something on line 28? Come on, is this real? Oh my lord. Oh, they might not like that these labels are different. ME underscore div, I'll just call it 2, 2, 2. Save it up. Nope. Okay, what don't you like? Some. I don't get it though, because reference REM undefined. Oh. You don't like EQ ref, maybe. Okay, is there some... Okay, I'm gonna copy and paste this thing that I've used in another document. Maybe that's what it likes. Nope. Okay, so right now I'm gonna do some Googling. Okay, so I want... Okay, like, do I need this package then? No? Alright. Maybe I should actually read this. Okay. Alright, this is frustrating me now. Yikes. So weird, man. Okay, so these, I guess, should be on the same line. Whatever, LaTeX, whatever. Can I use EQ ref now? Yes, and do I need ASA map? No, I don't. Perfect. And now I can do all this. Little things that bother me. Oh, amazing. Awesome. What don't you like this time? What the heck? What the heck is going on? What is it? ASN map? AMS. Okay, what doesn't it? I don't know, like maybe because I'm insisting on using EQ. Just whatever, dude. 500 LaTeX. Oh, I don't have the patience for this right now. Like, this is, I don't have the patience for this. Oh, yo, 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 yo. What is the problem? Why was it working and then, okay, but now the equations don't work? Am I doing, um, do I need a, like, do I need this? I'm really worried I'm gonna lose this one. So I better just paste that. Probably copy something else by accident. Okay, like. Oh my lord, multiple labels. Ah. Again, the use of an asterisk in the environment name determines whether the equation is numbered or not. Okay, but how do I label? Really? I have to do that? Blah, 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 blah. Alright, what does this say? Oh my god. Oh, yo, 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 yo. I feel like this is begin sub-equations. Don't give me that. I feel like this is becoming way more complicated than I intended it to be. I had to pick some more relaxing music, I think. Oh, yeah. See, label, label, align. Like, yeah, like why isn't there? Okay, I feel like this should be so simple. Oh my god, I'm such an idiot. Okay, well, at least one of the problems is fixed, at least. Do I have to do that? Oh my god. What is going on? I probably should have just used overleaf. Overleaf overlooks. Wow, okay, this is... I have no idea what's going on. Like, am I missing something here? Okay, yeah, okay, this is what I want. Okay, crossing my fingers, please work. Oh, yes. Okay, so now I'm gonna mess things up a little bit, probably. Oops. Oh my god. Okay, we'll undo that. Oh no, it's still not working? Really? Is this seriously not working? Okay. Ugh. And wait. Okay, whatever, it's working. Alright, finally, we can move on. Alright, that was annoying. Okay, moving on. Yes, and then this should be an omega. Right. Okay. And on the sum. This, and this is an E sub n. R. Okay, yeah. And then when I take the derivative of h with respect to t, I'll get the sum again, but I'll have to bring down minus I, so the minus cancel with this minus. I'll just get an I, and I'll get a omega n. I have to include that omega n in the sum, and then I'll just get an h. And then there won't be a derivative anymore. Now I'm going to put it under n under it. Okay. I'm going to take my life in my own hands here. This is going to be epsilon naught. I'll have a minus I. I'll have a and okay, the sum of n there, the omega n comes down, and this becomes an E. Fingers crossed, save it up. Yes, it works at least. I just forgot a period. Alright, so things are looking pretty good. Let's just see here. So let me just look at the textbook. Yeah. Okay, so now essentially what this is, what is this? Okay, let's rewrite these. I'm gonna rearrange equation qref eq on the all right, so I'll write the sum yeah, okay. So the first one is fine. I just want to write the sum in front of everything. I'll use square brackets. I'm basically just factoring out the sum. So I'll have a minus I mu naught, and then the sum goes away. This one, there goes H. Oh shit, what did I do wrong here? Never copy and paste, dude. This is why you never copy and paste. Oh, I'm getting hungry. I'm using too much brain power trying to solve all of my stupidities. Okay, let's see if I've done everything right. Yes, fine. Yeah, so I've just brought everything over. Okay. Oh, just stretching. Okay, I should probably save these. Okay, so these equations must be true. The equation is immediately above. Each frequency component. Should we say must be true? Or let's just let the equation, or say that in order for the equations above to be true, let each frequency component be equal to 0. I don't know, something like that. So now I'm just going to rewrite this shit without the sum. And this is what the textbook gets, which is good. And then I'll have to write these as, these might be the final expressions. Fin for final. Also French for finish. All right, that looks pretty good. Something like, I mean, my language is horrible, but whatever. Okay, so what do I want to do now? All right, so now we're going to write out the wave equation, I guess. Okay, sip of water. Spill water all over myself. Now we're going to derive the wave equation for what is it? This one, E and H. Or I've, neglected. Don't neglect things. Never neglect things in life, I guess. That leads to confusion. Okay, so okay, so take the curl of equation I could just use an equation. And the question is, do I want to label this equation? I don't think so. I will not be labeling this equation. How does that look? Oh, of course, something went wrong. Yes. Oh, yes, something else goes wrong. Perfect. Sorry about that. Okay, and we want no label doesn't work. that really work? Perfect. Okay, why doesn't that? Okay, whatever. Man, I hate this. I don't hate this, I just hate this compiler or something? I don't fucking know. Okay, so now take the curl of this, let's say a comma, and then use equation h fin. Will this one be labeled? Yeah, I won't label it yet because the one I want to label is going to be like where I have the speed of light in there and everything. So the curl of h is minus I. So you have minus I times minus I is minus, and we have an epsilon naught mu naught epsilon that, and then this curl goes away, and we're left with just, where did I go? Here I am. E n omega equal to 0. Oh, wait. What did I do wrong? I did something wrong here. I'm just scrolling through the textbook here. No, okay. Yeah, it's fine. Okay, this is fine. Okay. So if I want to write this in terms of the displacement field, though, my displacement field. Oh wait, no. What's that vector? There's a vector identity. Triple curl or something. Or like, just do vector. Or no, it's a double. Double curl. Where's this one? Okay, put this little one right there. Okay, so using the identity. Nabla times h, whatever, equals nabla, okay, that's a lot of nablas. C dot h minus nabla squared h. Have an equal sign there, right? Okay. Okay, back, yeah, just let me save some of this stuff. Nabla left this. I don't want times, I want C dot. Just let me give some room here. C dot E, yes, minus. I don't need that, I just need a okay, save it up. Oh no, what? Oh, I just made a spelling mistake. Of course, none of my equation numbers. Okay, yeah, okay. But if we use D instead, yeah, so if we use D instead, then why would we use D instead? Okay, so I don't want to do this. I actually want to erase. Yeah, no, that's fine. I don't want to use this identity. I want to say use yeah, I don't want to do that because I don't think that's going to be helpful. Okay. Use that spec D equal to epsilon dot times epsilon. Yes, that's consistent. Okay, I'm just doing this so I can get it into the same form as the textbook. So this is D and has important. Yes, this is the frac. So I'm just guessing it right now. I'm gonna take a look at it and see if I have everything correct. So if I, okay, that's D. That's just D. So I can get, yes, I have to get rid of this stuff. Yes, and okay, what do I want to do now? What's the point of doing this? Speed of light. Oh, shit. Yeah, sorry. I forgot an omega n, like, literally everywhere. Dang it. Rearrange. Okay. But this one, so I have a mu naught. Okay, so I think, yeah, this is looking better. But I should square this. Omega n squared. Those last two ones are omega n squared. Alright, and I want speed of light. Okay, so here, so use C, C squared equals 1 over not epsilon, that's epsilon u not. Okay, so I'm going to do that. So C squared, so mu naught is 1 over c squared epsilon naught squared, so there should be an 1 over mu naught, mu naught is c squared epsilon naught. Oh, 1 over. Does this sound right? 1 over c squared. Yeah. So this should be an omega m. So I'm going to have an epsilon naught. Right. Okay. Just checking the textbook. Checking the textbook. All right. What did I get wrong here? Okay, well, epsilon, this is 1 over c squared, so omega squared over c squared. Oh, I forgot. Epsilon. Right? Or we can say, then finally, I will label this one. I'm so hungry now. that's the textbook. That is the textbook. Okay. And I will label this as a EQ, and this will be wave EQ D. Wave EQ D. All right. So finally this. All right. Okay. All right, let me just do the same thing now for H. Yes, which is making me extremely tired. But we must press on. Okay. So now to do this for H. Okay, so do I want to show all the steps? You know what? I'm not going to show all the steps because I'm tired and I don't want to do it. And I've already done it once. I'm not going to do it again. Okay, that's for H, and it can be shown. So, and copy this. This would be wave equation H. It's the same thing, more or less. I'll just write it out again, I guess. Oh, that's a mistake. Same sort of thing, take the curl, blah, blah, blah. I'm just copying this from a textbook because I'm lazy. And I think after this I will definitely stop to go eat. And I will continue this another time. Because you can only do so much. Wow, this is annoying to write all this out. And the other side is the same. That's H. Oh, I forgot the end. Okay. Ah, yes, go this flag. Yeah, that's good. Okay, save that. Save this. And I just want to make sure. Okay, so what I did today, essentially just derived or copied the wave equations for the electric and magnetic field essentially inside of this slab. And so this dielectric function, yeah, okay, so the next time I will kind of look for specific solutions to these equations that have that match the symmetry of the structure, the dielectric function. Something like that. Okay.